Welcome to the next session of Answers APDL. In this session, we are taking up another numerical on a cantilever beam which is subjected to some point load and moment, as you can see in the diagram here. So here we have 4 elements and 5 nodes which I'll be creating using APDL. So let's start with preferences, structural, OK. Then I'll go to preprocessor, element type, add, edit, delete, add, beam, to node, OK, close. Then I'll go to material properties, material model, structural, linear, elastic, isotropic. I'll choose Young's modulus as 2e5 and Poisson's ratio as 0.3. Close this. Then I'll go to sections, beam, common section. Let me assume the breadth as 30 and the height as 30. OK. Next, I'll go to modeling, create key points in active CS. The first node is always at 0, 0, 0. Then I'll go for the second node. I can see here that the second node B is at 2 meters from the start. In fact, C, D and E are also at 2 meters from each other. So I will start plotting them. So it's 2000 mm. Then I'll go for third node, 4000. Fourth node, 6000. And fifth node, 8000. Next, I'll go to lines, straight line. I'll select 2 points at a time. OK. Then I'll go for meshing, size control, manual size, global size. Let me assume the number of elements as 10. OK. I'll go to mesh, lines, pick all. Plot control, numbering, element number. OK. Then I'll go to loads, define load, apply, structural displacement on key points. I'll go for node A. I can see here node A is fixed. All degree of freedom. OK. Now next, at points C and D, there are 2 vertical loads in the downward direction of 30 kilonewton and 20 kilonewton respectively. So I'll first select force on key point. This is node C. Fy minus 30,000 Newton. OK. On key point, last point E. OK. This is minus 20,000. OK. Next, I'll apply moment. So on key point, and I'll choose B. OK. Now the moment is about the Z axis. I can see here it is 20 kilonewton meter, which means it will be 20 into 10 raised to 6 Newton mm. And the direction is given as anti-clockwise. So I'll take anti-clockwise as negative. So MZ 20 E6. Apply. And at this node D, I'll again apply moment. The value over here is 30 kilonewton meter. So this will be positive 30 E6. OK. So I have applied all the boundary conditions. Next, I'll go to solution, solve, current LS. OK. Solution is done. Close. Then I'll go to general post processing, plot results, deform shape. deformed plus undeformed. So this is how I see the deformation in the beam. I'll go to contour plot, nodal solution, degree of freedom, displacement vector sum. I'll choose deformed shape with undeformed model. Okay. So this is a deformation on the entire beam. I can also see the stress over the beam. 1 minus stress. Okay. Now I want to see the SF and BM diagram. So I'll go to table, element table, define table, add by sequence number 3, apply by sequence number 6, apply by sequence number 16, apply, and by sequence number 19. Okay. So I've created all of them, close. Then I'll go to list results, plot results, line element resolution. I'll choose 6, 3 and 16. Okay. So this is my BMD. These are the various values over the entire beam. So I can just check from here. At this end A, it is 0 to 290 kilonewton meter. So if I have to convert this value of blue over here into kilonewton meter, I should be dividing by 10⁶. So this would be 265 as the value here. That's okay. And accordingly, I can check all the values from here. Like this light blue color here is indicating 236. This blue here is 207. This light green color is indicating this value here, 148. And this green in between, this blue and green, is 177. So accordingly, you can check all the values over the beam. Now let's plot the SFD. I can see here this blue color is minus 50,000. It will be Newton. So that is minus 50 kilonewton. Let's check. And here I can see this 20 kilonewton. So this is going to be minus 20 kilonewton as I can see here. Now this is showing negative because it is about the sign convention which has been used. Upward and downward, clockwise, anti-clockwise. So it's all about the sign convention used. You can either show the graph above the baseline or below the baseline. So that's about all the results. I hope you have understood the procedure for solving this numerical. If you have any doubts, please write to me in the comment section. See you in the next session. Thank you.